Welcome mathematicians. In this video we'll be looking at visual representations, banking investments and loans. In the area of finance maths, a lot of students have difficulties solving problems because they can't visualize the difference between different forms of investments and loans. So let's look at a few of the common investments and loan arrangements. So first of all, we have a reducing balance loan. In this example, we have a loan amount of $20,000, an interest rate of 10% per annum, compounding annually, and the annual payments being made to this loan is $4,000. So here's our loan amount of $20,000, where every little rectangle represents $1,000. At the end of the first year, we have interest that's charged to this loan. And from our information up here, it's 10% of the previous amount, which was $20,000. So 10% of $20,000. 10% can be represented by 10 out of 100. That gives us an interest of $2,000. So our loan that was $20,000, we now owe $22,000. But then at the same time, at the end of the first year, a payment is made. The payment we make is $4,000 in this situation, and that's removed off the loan. So the balance after 1 year is equal to the balance at the start at 0 years, plus the interest that's been charged, minus the payment that's been made. So we started with $20,000. We would charge $2,000 in interest, and then we made a payment of $4,000, which reduced our balance after 1 year to $18,000. Note, in this situation, the interest increases the loan balance, the payment decreases the loan balance. If this were to continue, we would find that each year the loan balance is reduced further and further until we eventually reach a loan balance of 0, where it's been paid out in full. Our second scenario is an annuity investment with payouts. This type of arrangement is used quite often in retirement, where a person will invest a lump sum, he will gain interest, but then they'll take payments from that particular account to live off. So the annuity with payments. So we have an investment of $20,000 again. The interest rate is 10% per annum. It's compounding annually, and there's annual payments received of $4,000. So this is not payments in terms of payments to the bank. This is payments coming from the bank to the investor. So here's our $20,000 investment at the start. At the end of the first year, interest is this time not charged but earned. So it's 10% of $20,000, which again gives us $2,000. So we started with $20,000 invested in the bank. At the end of the first year, we now have $22,000 in total. However, at the end of the first year, we have to receive a payment of $4,000. So once again, $4,000 is taken from this account. So the balance after the first year is the balance that we started with at $20,000, our initial investment, plus the interest that we earned of $2,000, minus the payment we took from the account of $4,000. So at the end of the first year, the annuity balance has been reduced down to $18,000, predominantly because we've taken out $4,000 to live off. Note, in this arrangement, the interest increases the annuity balance, and the payment we received reduces the annuity balance. Example number 3, where we've got an annuity investment. So annuity investment, we start with $20,000. At the end of the first year, we calculate the interest earned, which was 10% of $20,000. So once again, we earn $2,000 in interest. Now the payment in this situation, we're adding a payment to this balance to further increase its value. So the payment made is $4,000. So on top of our interest of $2,000, we're also making a contribution, a payment of a further $4,000. So with an annuity investment, the balance after 1 year, we're equal to our initial starting balance of $20,000, plus our interest of $2,000, plus our payment to the account of $4,000. This now provides a new annuity balance after 1 year of $26,000. So in this situation, the interest increases the annuity balance, and the payment also increases the annuity balance. It's continuing to grow every year, and that will continue to compound and get bigger and bigger quite rapidly. Finally, let's have a look at the perpetuities. So we start with $20,000. At the end of the first year, there is interest earned on our account. So 10% again of $20,000. That earns us $2,000. So we started with $20,000, the blue rectangles. And then at the end of the first year, we've earned another $2,000, the green rectangles. However, with a perpetuity, the interest earned is exactly the same amount as the payment received. So in this case, we earned $2,000 of interest, and now we're withdrawing that as a payment. So payment received is $2,000, and that's removed. And as you can see, we're back to our original starting value of $20,000. The balance after 1 year is equal to our starting balance at 0 years, plus the interest minus the payment. So we had $20,000 at the start, we earned $2,000 of interest, and we removed or took out or received $2,000 of payment, taking us back to our starting value of $20,000. A perpetuity always remains perpetually at the same balance at the end of every period. Please note that in a perpetuity, the interest increases the investment, the payment decreases the investment. But this is a special case where the interest is exactly equal to the payment. Thanks for watching this video. I hope this video has given you a visual representation of some of the most common banking problems we find in further maths. If you found this useful, please like, share, comment, and subscribe. And as always, thanks for watching.